Hello, 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 hello. Can you hear me? Hello,
Hello, can you hear me? Hello?
given us things that are subsequence. Note that even if there are multiple ways to obtain the same sequence, it is not only counted once. A palindrome is a string that reads the same forwards and backwards. Okay. A subsequence of strings is a string generated from the original string with some extra characters deleted without changing the relative order of the remaining characters. For example, ace. For example, ace is a subsequent. The heck? Okay, I'll just copy this and paste it here so that I get an explanation. Explain this question and give a step by act as a mentor and give a step by step guidance on how to solve this problem. Use simple words.
Yes.
Explanation. Nice problem. You want to count distinct palindromes of length 3 that appears as subsequence in a string. The length 3 palindrome has a form XYZ. Same character at positions 1 and 3. We only count each distinct strings like ABA once, even if it can be formed in many ways. For each letter C, think A to Z attack. Okay, so we are given a string like A B C A. Output is 3. The palindrome sequence are ABA, subsequence of A B C A. Okay, so A B A subsequence of A B C A. So that becomes A B A. A and C are not counted. Where A, this triple A. Starting and ending letter the same. Here A C A. Example ADC0. There are no palindromic sequence of length 3 in ADC. Okay, so the length has to be C and there have to be two letters that are in the string. So here B B C B A B A. Output is for the palindromic subsequence are B B B B B B. Okay, B C B. Okay, B A B. Mm, A B A. Okay, so key observations. For each character, C think A to Z. Find the first position L where C appears and the last position R where C appears. If L is less than R, then characters that appear between L and R can be the middle. Find the position. Okay, step-by-step solution. Initialize an answer counter ans is equals to 0. For each letter C from A to Z, find the letter L if first index of C. Correct. Next. Tin, 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 Example walkthrough. Okay, first I have to initialize the counter C. So I have to let me set the counter C. Then I'll have they given self. So here self what's a self? Okay, maybe that's the string that they have given. Order of zero. Okay, a subsequent of strings is a new string that can be generated from the original string with some characters can be deleted without changing the relative order of the remaining strings. So here A B C D E in that I can remove B and D, so that becomes ace. So that's a subsequent string. Let me copy this and add them in my notes. From it and forms a new string. Okay, that's what I understood from subsequence of a string. So it has to be subsequence and it has to be a palindrome. This is what I understood. So here it's AABCA, and the subsequence of AABCA is ABA, because you remove B and C. No, you remove C, it becomes ABA, and if you remove B and C, it becomes AA, and if you remove B, it becomes ACA. So it's like a palindrome, right? So this is listed from the question. Initialize an answer counter. So we'll initialize ans is equal to 0. Okay, for each letter C from A to Z, find the letter L such that first index of C is non-scalar. Complexity is O of n plus 26 into inverse case if you're checking subsequent. Natively efficiency is O of n because 26 is a constraint. Each case if the character appears only once, it cannot be outer characters of length 3 palindrome script. Middle character can be the same as the outer character. The string may contain only lowercase. Okay. Damn, this question is so hard. It's a medium level problem, but I feel it's hard. Okay, so it's hard to understand the question itself. For I in CH in enumerate. What does enumerate mean? ENUMERATE, meaning enumerate, mention a number of things one by one. Enumerate. Add this to my notes. We're learning new things. Subsequent is string that has a character deleted from it. It forms a new string. Enumerate mentions number of things one by one. Okay. N is equals to length of S. So S is the string, right? So take the length of S. Pre-compute first and last occurrence of each character A to Z. First is equals to minus 1 into 26. Last is equals to minus 1 into 26. For I in C, for I CH in NU, dx is equals to what's ORD? Let's explain each line of the code using comments. Okay, first create two list of size 26. First I will store the first index where letter A plus I appears. Last time it will store the last index where A plus I appears. Initializes all values as -1. So initially it will all be -1. Let's do initial. First occurrence will be stored in here into 26. Last will be stored here into 26. For I ch in enumerators. Okay, convert the character to a number 0 to 25 is equals to 0, b is equals to 1. Okay, id idx is equals to ord of ch. What's an ord? Order? A function returns a Unicode point to the character ch. Okay, it's like ASCII value. So ORD is AF19. I think it is ASCII value. As ASCII value of A96, I think. No, it's 65. So what is the difference? Okay, ORD meaning of ORD. ORD function is a built-in Python function that returns an integer expression, the Unicode point of the specific character. In simpler terms, it translates a single character into a number that the computer uses to identify that specific symbol. So ORD of A is 65. Okay, it is like ASCII value, so you do that. Okay, so you take that ORD. If first, okay, it takes a number of time each letter is repeated. If if this is the first time we see this character store the index. Okay, idx is equals to -1. Idx is this one. So we store that number, and the last time it appears, we store that number. Last time it appears, we store that position. Always update the last occurrence. Idx is equals to 1. Okay, for check every possible character A to Z as the outer character in range 26. L is equals to first occurrence of this character. R is equals to last occurrence of this character. Okay, let me just Google this question once. I'm sure there are people who can solve this question as though it's nothing, it's a piece of cake, but I can't. Google, YouTube. 3 unique length 3 palindromic sequence lead code 1930. Yes. Okay, so let me change the screen. Oh, zero screen as usual.
Hey everyone, welcome back, and let's write some more 3 palindromic subsequences. This is a problem from today's LeetCode contest, so we are given a string s. We want to return the number of unique palindromes only of length 3 that could be a subsequence of s, not necessarily a substring, but we're given something that's even more generic, a subsequence of s. And when they say unique palindromes, basically we can't use the same one twice, even if the characters or the subsequences of the string allow it. For example, over here, we have one subsequence, A, B, A, right? The first A, then one of the B's, and then the last A. It forms this subsequence. This is a palindrome, right? But we could have gotten the same exact palindrome if we skip the first A and use the second A, B, and then the last A, we could get the same one, but we don't want to use it twice. In this case, we can get 3 palindromes, and these are the 3 palindromes, and you can see how they form a subsequence from the given input string. So just a quick disclaimer. I'm going to be showing you the solution, at least the best that I could come up with, which is a 26 times n time complexity solution, and the memory complexity is going to be big O of n, where n is the size of the input string s. This is the best I could come up with. If you have something better, I would love to hear it in the comments. Definitely let me know. But so let's kind of go through some of the logic of how we can arrive at this solution that I could come up with. Maybe there's a better one out there, but this is the one I'm going to be explaining. So the good thing is that all the palindromes just need to be of length 3. So even if we wanted to do a brute force solution, we don't actually have to get every single subsequence of the string s. That would be a time complexity of 2 to the power of n. That's how many subsequences.
Nice to meet you. Okay.
We can get. But if we want to get every subsequence of length 3, big O of n to the 1 pointer would just be every position. We'd have nested loops. Would be 3. We just need as we can get. But if we want to get every subsequence of length 3, we just need 3 nested loops, right? So the time complexity for that is going to be big O of n to the power of 3. How could we do it with 3 nested loops? Well, basically, we'd go through every single 1 pointer would just be every single character, right? So we'd have 1 pointer, starting at the beginning, going through every single position. We'd have a second pointer that would always come after the first pointer, and that would go through every position as well. And we'd have a third pointer that would come after the first 2 pointers. It would go through every position as well. So it'd just be a standard triple nested for loops, just going through every single character of this. And then for each iteration, we would check, okay, let's say this is the palindrome that we're currently looking at, or the subsequence that we're currently looking at. Then we'd see, is this a palindrome or not? We'd add it to a hash set to make sure that we don't get duplicate palindromes. First of all, this isn't even a palindrome, so we would not add it at all. But if we did find a palindrome such as this, we would add it to a hash set to make sure we don't have duplicates. And then at the end, we would basically return the length of that hash set, which would tell us how many palindromes of length 3 we were able to get. And this isn't the worst solution, but we can actually do better. One thing they tell us is that all characters in the input S are going to be lowercase a to z characters, so 26 characters total. We can use that to our our advantage. And we could also use the fact that this is a palindrome only of length 3. Is there anything that you notice about palindromes of length 3? Well, one thing I notice
Two
about palindromes of
letters.
length 3 is the middle character could be
Is
any character, right? It
yeah.
could be any of the
So
26
we go back.
characters. So it could have 26
No.
different characters.
So we
Now, if we
go to
choose a
each
middle
letter.
character, then the
Check if
left
the first
character
one
and
is
the right
other
character
same.
have to be the exact
Yeah,
same, right? So since the left and right character have to be the exact same, and the middle character could be any character, basically how many palindromes of length 3 are even possible if we have 26 characters available to us? It's going to be 26 squared, because we're going to have one spot for the middle position, and we're going to have 2 spots for the left and right position. And these left and right positions have to be the same, right? It could be A, B, C, anything, but they have to be the same. And the middle character could be independent of the left and right characters. It could be anything as well. It could be any of the 26 characters. So we have 26 squared different palindromes we can make. Now, knowing a little bit of that intuition that I just explained to you, how can we actually go about finding these palindromes without doing a triple nested loop? Well, let me show you how we can do it in big O of 26 of n. So I'm going to show you the big O of 26 of n solution. So we're going to have a hash set, and I'm going to use the idea that I just showed you. Instead of having a hash set where we actually store the 3-character palindrome, I'm just going to store a key where we have the middle character and the outside character, right? Because we know the outside character is going to be the same, so we don't have to have 2 values for it. And the middle character could be independent. So, this key could have up to 26 squared possibilities. And so this is where I'm going to put those inputs. And so we're going to have a string like this one, and I'm going to just iterate through this once, and I'm going to show you how we can do that. So I'm going to have a pointer, and I'm going to call it M for mid, right? It's going to go through every single character in the input. Now, since M is going to be the middle of our palindrome, we can just kind of not consider the first character because it doesn't have any characters to the left. So there's no way we could form a 3-character palindrome if this was the middle character. So let's start over here. So this is going to be our mid. In theory, how many possible different palindromes could we form where this is the middle character? Only 26, right? Because we only have 26 characters. Why? Because A is going to be the middle character, obviously, right? That's very obvious. A is going to be the middle character in this case. So the 26 comes from, well, do we have a A on the left and on the right of this middle character? If we do, that's one palindrome. Do we have a B on the left and a B on the right of this character? Et cetera, all the way up until Z. Do we have a Z on the left and a Z on the right? And when I say, do we have this character Z on the left or right, I mean anywhere to the right or anywhere to the left, right? Because when we say subsequence, that means they don't have to be contiguous, right? So that's exactly what we're going to do. For every middle character, we're going to do a for loop for character in A, B, C, all the way to Z. And I'm going to check, do we have a matching character on the left and a matching character on the right? If we do, we can count this as a palindrome, a 3-character palindrome. If we don't, then we can't count it as a palindrome. Now, how can we check efficiently? Well, one way would be just go through, right, for, let's say we're looking for A, right? Just iterate through every single character on the right, iterate through every single character on the left. If we find an A on both sides, then we can count it, right? Now, if we do it like this, the overall time complexity of the solution is going to be 26 times n squared. That's not bad. That's better than n cubed, which is what we had earlier, but we can actually get this to be just 26 times n. Let me show you how. And hint, we're going to need a hash set just like we have for our result. So we're going to have a left hash set, which is just going to tell us all the characters, all the unique characters we have on the left side of our mid pointer. I'm going to show you how we're actually going to be keeping track of that in the code because I think it'll be a little bit more simple. I don't want to overcomplicate this drawing. So that's what we're going to use to keep track of what characters on the left. If we have a hash set like this, then for every time we get to a middle character like this, then we can check in O of 1 time for each character, A, B, C, etc. if we have that type of character that we're looking for on the left side of our middle character. We can also do the same for the right side, but we're going to use a hash map for that. I'll show you why exactly we're going to do that in the code, but the main thing is as we move our mid pointer over and over, we're going to be removing characters from our right hash map, and we want right? Because we only have 26 characters. We have a on the left, so to a 4 character. How can we and need a hash set because we have on the left to keep track of B, C, etc. That I'll show you why exactly we're going to do that in the code. But the main thing is as we move our mid pointer over and over, we're going to be removing characters from our right hash map, and we want to have a on the left. Have a on the left.
Bye bye.
Bye. Lagi listener sampo.
To be able to count how many of each character is in the hash map so far, because then once we, let's say, remove an A, once we remove the third A, then we know we don't have any A's left in our hash map. So then we can actually pop that A from our hash map. But so that's basically the intuition, right? So that's what we're going to do. We're going to be using these data structures to get the time complexity to be linear. And like I said, there might be a better solution. If there is, definitely let me know. But this is the best I could come up with. So that's going to be the idea. We're just going to iterate through this entire string once with a
The heck? Right of is to the I is equal to -1. Okay, if right of s is equal of I is equals to 0, pop it. So he's made like a stack, I guess. Okay. No question. Learn what a hash set in the hash map is. Some new stuff. For what I've learned, hash set is something. I don't know. Hash is something where you assign a number or some character to another set of number. So that's a hash. I don't know what a hash set is. Nah, mean. Hash. Mhm, 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 mhm. Oh shit! Here we go again. What's the error? Okay, count palindromic subsequence in line 14. Palindrome 7, parameter 1. That takes directly exactly one argument given to. Okay, the heck is it not add? What if we add another bracket here? So, oh no. Okay. Set left, set right. Connections of counter is. Yeah, let's see if the indentation's right. Indentation is white. Mhm. What in the world? Dynamic subsequence. How is his thing collection set? Yes. ECT is not count. Okay, so it's outside the loop. It has to be outside the loop. Okay, so this is indented if or again, and if how is it wrong? Okay, R equals to R. This line is wrong because right is the counter holding counts. S is equals to A, B, C, A. Then initially A is 3, B is 1, C is 1. You wanted to decrease the count by 1, but you wrote count. Okay. Ah, it's minus equal to 1. Okay, so is equals to minus equal to 1. Okay. So here's a set of right side and left side. Mode of truth, yes. Runtime is 0. So let me submit it. Okay, something's wrong. No, completed day 34. Hooray! Let's see. Runtime, okay. 85 milliseconds. Okay, that's bad. But something's better than nothing. And I also have to write a note. ORD converts A to a number. Okay, here it is. So RES is the right side and this is the left side of a string. So it goes through each character and it checks if the character in the left of the current node, the current element, and the right of the current element is the same. So right is equals to collections of counter s. For I in range length of s, right is equals to s of I is equals to minus 1. So each time right is a collection of counter s. Okay, so it takes the thing, the number. I think it's more like a length, I guess. And each time it keeps on decreasing, so it's the maximum value. So if right of s of I is equals to 0, right dot pop s for J in the range 26, CHR C is equals to character of order of A plus J. If okay, I don't understand this line. ये भैया ये भैया explain this line. What does this do? And these lines mean something. What does it count how many times each character appears in a string? Mm. Okay, ha ha ha. Something like this. This is what it does. Okay. Okay, this line converts a number back into character. No, okay, this is, I mean, this character repeats 0 times. And then it pops it. Right. Hmm. So, let's see. Control of S. Each time goes there. Okay. J in the range 26. This line converts a number back into character. Plus J in the range 26. Okay, so it takes the order of CHR. What is CHR? Character of C. Okay, goes to each letter. If C in the left and C in the right side, just dot add C of I over C. Alright guys, if you like this video, please like, share and subscribe to my channel. Peace. Whoosh. Dee 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 dee.